board. Right. So, welcome to Oxford Philosophy of Physics. This is the last seminar in this term's seminar, and it's a great pleasure to have Jenann Ismael give us a talk on a topic that has been very central to a lot of her work. Jenann began at Princeton working with Bas van Fraassen, then moved to Arizona, and then recently, I think just last year really, to Columbia. And Jenann's work has focused primarily, I would say, on probability and time, and different aspects relating to both, but many other themes as well. Today, Jenann, your title is, talk me through it, I don't see it written.
Totality, self-reference, and time.
And time, yes. Well, what a title. So excellent. Thank you, Jenann. It's a great pleasure to have you. Take it away.
I've actually been at Columbia since 2018, so a few years now. But thanks Thanks so much for inviting me. I think in many ways, maybe the best thing that's come out of the pandemic is the ability to kind of sit in on. Carlo, I think you're unmuted. Has been the ability to sit in on these seminars. I'm really, really delighted to be here. And I should say that this is going to be a little more kind of philosophy and a little less physics than some of the other seminars, though it's kind of the philosophical edge of physics. So I hope that it will still be interesting. It's a little more raw than I would like. So this stuff is incredibly hard to get a handle on for me, I think. So, but that means there's lots of room for things to talk about and lots of room for me to learn. So I'm just going to dive right in. So any attempt to describe the universe as a totality inevitably involves self-reference. So this isn't something that one often confronts in physics. Most day-to-day physics, one is kind of modeling other systems, so cells, gases. We maintain a provisional separation of subject and object, or investigator and system being investigated. Cosmology is the physics of totality, so you might think it should arise there, but it's sort of customary in cosmology to maintain this sort of imaginative fiction that we're sitting outside the universe, kind of looking down. Ultimately, though, we are part of the universe. We exist. So however we regiment the universe, or whatever regime we work in, if we aim for a theory of our universe as a whole, self-reference is unavoidable. And it's not going to matter in some contexts, but it will matter in some. And I think that the people that have unavoidably encountered it, interestingly, oops, sorry, I didn't mean to go there yet. Did not mean to go there yet. Are people that are, for example, trying to program an AGI, so an artificial general intelligence in a robot, kind of an embedded agent. So they want to program a system with a bunch of general knowledge and the ability to model the world. And they're coming up against the fact that there are going to be problems of self-reference. So the problems arise because some of what happens is stuff that the computer does. So let me give you a simple example. Suppose you want to program a computer. So it's just a simple device. It's going to be our kind of grand overarching database or repository of information about everything. So we set about programming it with as much factual information as we can about the world. You program it with the laws of physics and all of the scientific knowledge we've kind of amassed, facts about how the monkeys of Costa Rica, facts about monkeys of Costa Rica and the vast reaches of space. And the goal is to be able to put any question of physical fact to it. And the answer will appear on a monitor in an output channel. Okay. Now it's not hard.
But it appears, Jenann, do you have slides that you're sharing?
Yeah, they're not shared.
Oh, it looks like we're not seeing your slides.
Okay, thank you.
Sorry about that.
No, it's me. I didn't share my slides. Go figure. Okay, wait. Share screen. Thank you for interrupting. So I'm going to go back just one. Let me see. Share. So you're seeing them now?
We can see them now. Thank you so much.
Okay, no, thanks for stopping. Okay, wait, so let me see if I can, yeah, okay. So this is where we want to be. Okay, so the goal is to be able to put any question of physical fact to it, and the answer is going to appear in an output channel. But it's not hard to find a question that it can't answer truthfully. Just ask it, is the answer that's about to appear, is the answer that's about to appear in the output channel? No. So this might seem like a little logical glitch. These kinds of problems are familiar to philosophers and certainly to computer science. The problem is that, as I said, what the computer does in giving the answer to the question interferes negatively with what the answer says. So computer scientists know that self-reference leads to paradox, and we don't want to build the potential for paradox into an artificial general intelligence. So the first reaction is to try to suppress it or keep these sorts of questions from arising. Okay, so this is a little bit more subtle to accomplish than you think, since there's nothing wrong with the question that's being asked. It's a question about a perfectly mundane matter of physical fact that any other computer could answer truthfully. It's and indeed that it could itself answer truthfully at other times. Another reaction is to just kind of acknowledge the difficulty and try to quarantine it. And again, it's a little bit more difficult than you think if the word no appearing at my screen at T is going to affect the truth values of other propositions. So maybe other computers in the room are going to record my answer, or maybe they're going to form beliefs about it. What do I say about their beliefs and so on? So do I withhold truth values from all of the propositions which they record? And again, of course, truth value gaps just aren't the kinds of things that we like to introduce into a logical system. Right? Whatever you do about it, it's usually thought that self-reference is a pathology. You want to get as close to minimizing any disturbances that the computer's own activity has on the truth values of sentences in the fields of propositions that it's representing. Okay? And the reason that the problem arises is, again, clear, is that by saying things, the computer is doing things. And so we can get a kind of interference between what it says and what it does. And if the interference is negative, which is the way paradoxes are sort of rigged up, that is, if it says conflicts with what it does in giving the answer or in saying what it does, that keeps it from being able to stabilize the facts that it's representing independently of what it says about them. Okay? So that's what's going on with paradoxes of self-reference. You can't stabilize the fact that the answer is meant to describe the word that appears on the output screen independently of giving the answer. And the thing is set up so that no matter which answer you give, what you do in giving is going to conflict with what you say. So negative interference can arise in other ways. I offer you a $100,000 bet for $1 to predict the output of a simple deterministic switch that's going to go up or down depending on the input. The glitch is that you have to tell me your prediction, and that's the input that I'm going to give the device, and it's set up to do the opposite of what's predicted. Okay, you shouldn't take that bet. Okay. Now, positive interference can arise too. So a positive interference or interaction effect is just a self-fulfilling prophecy. So a man's insecurity about keeping his commitment-shy lover drives her away. A favorable prediction by an influential analyst drives stock prices higher. Now, any system that's acting in the domain it is representing is going to encounter interaction effects, and they can interfere in complicated ways with pure representation or pure knowledge acquisition. Okay? If you're lucky, you can quarantine them, but the more connected things are, the more difficult it's going to be. Okay? This stuff is messy. It interferes with what we're trying to do when we're trying to get a clean understanding of the intrinsic structure of a domain. We ignore it for good reasons when we're doing physics. Okay? But it arises naturally and inevitably for a system that's part of the domain that it's representing. This isn't a problem. I'm going to suggest it's actually a solution to a problem, because I think it helps us understand something that's otherwise very difficult to understand in physics. Okay? It's a sort of the final piece of a very complicated puzzle in understanding our own relationship to time. It also touches on two Penrosian themes, bringing us right in a nice way back to bringing the seminar series back full circle to that lovely first talk in the series from Martin Lesurde about Professor Penrose's work in the 60s. So the two Penrosian themes are, of course, self-reference and time. And I want to bring the discussion back in particular to Professor Penrose's papers, Singularities and Time Asymmetry, and show how this simple logical point set against the right physical backdrop can help us begin to understand something about the contours of our relationship to time that was diagnosed most clearly in that paper. So here's Professor Penrose. He says, the arrow most difficult to comprehend is ironically that which is most immediate to our experience, namely the feeling of relentless forward temporal progression, according to which potentialities seem to be resolved into actualities. So of course, we tend to universalize this sense of transformation of potentialities into actualities, and to think kind of pre-theoretically that the universe as a whole is a single synchronous process of becoming. Relativity does rule that out. It doesn't, however, rule out the idea that temporal progression for an individual creature that's actively kind of producing its future is properly understood as a transition from potentiality into actuality. It just means that there's going to be some asynchrony between what's going on along the world lines of creatures at a distance from one another. And what I want to suggest is that when we see how self-reference plays out against the background of a thermodynamic gradient, this actually makes good sense. We just have to take very seriously the idea that we are part of the world and that we're acting in a setting where there's a thermodynamic gradient. Okay. So there's lots of unanswered questions of both, principle and detail about what the various arrows of time in physics, how they should be understood. I'm going to just assume that we have all of those more or less worked out. So here I'm going to assume a broadly Boltzmannian account. I'll assume the classical laws, the canonical probability distribution, and a low entropy past, that those things together entail thermodynamic generalizations. But I think nothing that I say will depend very specifically on the parts of that account that are sort of heavily disputed or not well understood. So what's really crucial for my purposes is that the low entropy past makes the macroscopic environment so rich with records about its macroscopic past. Okay. So, and that feature of the thermodynamic gradient creates the conditions for the emergence of creatures that use information to guide behavior. So assuming about our world, whatever conditions are needed to support the emergence of complexity and life, assuming competition for resources and mechanisms for heritable selection, assuming the mix of regularity and randomness that we have in our environment, you can kind of see how evolution would reward increasingly sophisticated ways of using information. So the tangible signs of predator and prey will be available to any creature moving through a forest or a field. Such a creature doesn't actually need to represent time, okay? But a creature that stores large bodies of information, organized temporally, that can extract predictive regularities and use them to kind of avert, promote, facilitate, or defray events, that is a creature that can plan and strategize with an eye to specific ends at some temporal distance in the future, will have an advantage in an environment like that. So that's the kind of thing you are. And what we're trying to understand here is what the temporal experience of a creature like that is. That is a creature that's explicitly representing time at both a kind of long temporal horizon into the past and indefinitely into the future. Okay. So until now, I've been using the notion of agent in a small a sense and referring to anything that acts in a small a sense. So any material object, from a rock rolling down a hill to a snowflake melting in the sun, is an agent in that sense. Okay? Because some of what happens is stuff that it does. But from here on, I'm going to use the notion of agent. I'm going to capitalize the A's and use the notion of agent and act in the sort of in the most sophisticated and developed form that it takes in you and me. So I'm going to kind of leapfrog over all of these agents in the medium A senses, that is steps along the scale of increasing cognitive sophistication, from dogs kind of moving around their neighborhood with their nose to the ground, and ants leaving pheromone trails to mark paths to the locations of food, and squirrels burying nuts for the winter, right to systems like you and I, systems that explicitly represent time and choose behaviors with an eye to the records that they will leave. Okay. So all of the systems along this scale are in some ways using the record-bearing properties of the environment. Right? And it's a thermodynamic gradient that creates conditions for their existence as agents in these intermediate senses. But we don't know a lot about the way that other systems manage temporal information. And in some ways, it's easiest to kind of start with a fully articulated framework and then see shadows of this structure in creatures that are doing less explicit representation. And obviously, in our own case, there's a kind of touchstone for accuracy because we have our own experience to go on. It's not sort of merely conjecture. Okay. So the natural thought that a lot of people have had to try to ground the psychological time, the kind of psychological time in the era of entropy, is that we can see that entropy creates, the era of entropy creates an asymmetry in the amount of information that we have respectively available to us respectively about the past and about the future. So David Albert is the one that's most explicitly shown how to derive the epistemic arrow. And here's how you do it. Here's how you represent the information, that is to say, that's available to an agent with access to the macroscopic state of its environment in his framework. So you assume an idealized agent, and David, pipe in if I've got anything wrong, please. So you assume an idealized agent in the setting with thermodynamic gradient. She has access to the current surveyable macro state of her environment. You assume the classical laws and the low entropy past. The information that's available to her is derived like this. So you take the current macro state, apply a statistical postulate that says that the initial micro condition of the system of the world was located in any particular subregion of the volume associated that is proportional to the volume of the subregion. Okay. So you put a probability distribution which is uniform with respect to the standard measure on phase space over all possible microscopic histories of the world, which are compatible with the microstate or with what's known about the macro state of the world. And then you evolve that distribution forward using the dynamical laws. That will tell her generically to expect thermodynamic behavior. So she will know not to expect objects to spontaneously combust or ice cubes to form out of nothing. And she can use that together with other bits of specific knowledge to make predictions about how particular systems will behave under controlled conditions. but she won't be able to predict, for example, what path a skier will take across a particular patch of unbroken snow in the next 10 minutes, or whether some animal will find its final resting place in a particular patch of earth in the next decade. Okay. To get information that's available to her about her past, you will evolve that same distribution backwards, but this time conditionalizing on a low entropy state in the distant past. So now it's going to be easy for her to tell which path the speaker took through a particular patch of unbroken snow, right? And that an animal was buried in the place where you find bones a decade later. And in general, conditionalizing on the low entropy past is going to make the current macro states of semi-ordered, adiabatically isolated systems in the environment carry traces of earlier events. Okay. Specific information about their past of the kind that we don't generally have about the future. So footprints, fossils, melting ice cubes, decaying bones will be remnants of even more early ordered states in the past that can be projected backward from their current state when you conditionalize on an earlier low entropy state. Okay. Now, a view that wanted to ground the sense that the future is open on the epistemic arrow, okay, would say that the transformation of possibility into actuality is only at the level of epistemic possibility. So the sense of openness comes from the fact that we simply know less about the future. Okay? So Penrose considers, and rightly, I think, rejects this. So as he says, the direction of psychological time, says in that earlier paper, entropy and time, no, singularities and time asymmetry. He writes, the direction of psychological time is not just the question of being apparently more certainly, of the past being apparently more certainly knowable than the future. It's not the ease of inferring the past that's relevant here, but the feeling that the past is unchangeable. It's not the difficulty that we might have in guessing the future that concerns us, but the feeling that we can affect it. Okay. So the kind of unfixity in question here is something more than the merely epistemic sense. And you can see this, I think, by thinking about the difference between time and space. So when you cast your eyes across a landscape, you think of the landscape as a fixed object that's simply coming into view in stages. Right? But we don't think of the future that way. We think of the future as coming into being as it is experienced. So if you work in general relativity or something, you probably have a more disengaged view of time. But for most people, kind of actively engaged in the process of living, this is the most basic pre-theoretic difference between time and space. And it's fundamental to the experience of the embedded agent. You might think, so much the worse for these sorts of squishy pre-theoretic intuitions, but I think it pays off to be a little bit more patient with this stuff. It's clear that there's something that we don't understand very well, and it's worth trying to get it exactly right. I think that sense of the universe coming into being as it's experienced, rather than just coming into view, might hold clues about what time is, or what time is for us, that will help us in getting kind of the sharp edges of our worldview to line up right. Okay. And what I want to suggest is that the problem with the epistemic reading is just that it doesn't take into account the fact that we are part of the universe, and that our knowledge gathering activity is itself connected in the world that it represents. So instead of suppressing self-reference and treating ourselves as just observers outside the universe, let's see what happens if we take into account, take into account that we're part of the universe without presupposing anything more than the ingredients above. So classical laws, low entropy past, and canonical probability distribution. So go back to the computer, trying to answer factual questions about the domain in which it's situated. So the computer, remember, it can't truthfully answer the question, is the world the word that's going to appear on the monitor? No. Or the predictor that can't predict the behavior of a simple counter-predictive algorithm. So the thing about those cases was the problem wasn't ignorance. It wasn't missing information. Okay? It was that there was negative interference between what the system is doing and what it is saying. And the potential for interference, as I said, arises for any system that's acting in the domain that it's representing. So if you're trying to build a system that's just going to be a passive repository of knowledge, that's just a logical glitch that you want to suppress. But if you want to embody the intelligence so that it can use its knowledge to guide its own behavior, which is the whole point of intelligence from a natural perspective, you realize that this is not a cute logical glitch. A system like this knows that its knowledge has interaction effects in the domain that it represents. And instead of suppressing or nullifying those effects, it anticipates and it exploits them. So I'm going to pause here to be explicit about a couple of things. Okay. So it's really hard to recognize self-reference if you're just looking down at a physical description of the world for a lot of reasons that anybody who's spent time thinking about the mind-body identity statement knows about. You don't look at some state of a brain of a physical system and think that event is this thought. But your mental life is implicitly included in the physical description of the world, in a sense that it's subsumed under a functional description of processes mediating the perception to action pathways in a human body, namely your body, a particular system in the world. Okay. You do this naturally with other people when you describe or predict what they are thinking and doing, and you do it for yourself when you vocalize your own thoughts. Right? You think, here's what I'm thinking. Now, the reason in part that I told the evolutionary story that I did above when I talked about small A agents, medium A agents, and so on, was in part to get you in the frame of mind of viewing what's going on in your brain as just an ordinary part of physics, described at the functional level that calls attention to what the process is mediating the perception to action pathways in your body was selected to do. The underlying processes in your brain were arranged to support intelligent processes, okay, in the way that the hardware in a computer is designed to support information processing. And obviously, everything that I'm saying here is taking a clear side on the mind-body problem. But if you're going to be a naturalist, this is the kind of thing that you should say. And it's a very weak kind of naturalism. It's one that supposes that my mental processes are included in the dynamical order of the world. Okay? You can actually be completely neutral about the more disputed aspects of the mind-body problem. You can be a full-on dualist about phenomenal consciousness if you want. It's not going to matter at all to what I say, because indeed those particular aspects of the mind-body, those particular features of your mental life that, for example, worries about phenomenal consciousness focus on are precisely the ones that are dynamically inert. So also, normally when we're representing the world in day-to-day life, we're not representing our own current mental processes. So we do it sometimes, but usually our focus is outside. We're looking at what other people are doing. We're looking at what our bodies are doing and how they're moving. That's why I also put things in terms of recognizing that our own internal processes are connected in the domain that we're representing, and they're connected by way of their effects on the observable motions of bodies. Okay? So even if we're just representing the macroscopic events and the publicly observable, kind of publicly available landscape, if you're thinking about what to do, you're recognizing that your own thoughts are connected in the landscape, and you're exploiting the interaction effects of your own thoughts. So implicitly or explicitly, you are locating your own current thoughts and decisions and so on in the dynamics of the domain that you're representing. And the suggestion is, if you were to make the logic of your representation fully explicit, you should be able to find self-reference in them. Okay, finally, if you're thinking to yourself, look, I just don't get it. You can describe everything just in terms of physics, one event, then another, no trouble, no paradoxes, no self-reference. Okay. The same is true with the computer. We can describe the computer at the level of hardware, electricity flowing through transistors, pixelations on screen, without saying anything about representation, without getting any sorts of paradoxes. Of course, that's correct. There's no threat of contradiction or constraint at the level of physics. The problem is entirely at the representational level. So if you've got representation up and running, whether in a computer or whether in a human mind, and the system that's doing the representing or the representation itself falls under its own scope, there's going to be self-representation at the semantic level in the content of the representation. So most of the examples of self-reference in logic are static. It's people looking at logical relations among eternal propositions that have their semantic properties kind of essentially. But we're interested in physics, so we're interested in representation as an embodied activity. We're assuming that the universe is a field of events, and self-reference is arising because some of what a system that is representing is also what the system is doing. Okay? And that's going to create interference between these two levels, between the representational level and the physical level. We can rig it up as we did with the self-refuting question that the computer asked, right? So that the interference is negative. But this isn't going to affect anything at the about what a system can do at the physical level. It places constraint on what the systems can truthfully represent. Okay. So let me repeat this now all in application to you. You're an embodied intelligence. You're in the business of representing the world. You are acting in the domain that you're representing. Right. So you're negotiating two, and what I'm going to be talking about is negotiating two levels, the physical level and the semantic level. Okay. There's no avoiding that there's going to be interference between them. Representational activity is part of the physical world. It's connected to other things in the landscape. What happens, sort of every physical act is going to register at the representational level. And every representational act is something that's happening in the physical world. So what I'm going to be looking at is just seeing how that plays out at the representational level in the mind of the creature that's doing the representing. And I want to emphasize that this isn't just psychology. So it's not just about understanding, what time is for us or the experience of time. Intelligent activity is part of physics. It moves Earth and it builds cities. Intelligent activity kind of hacks natural processes and becomes the dominant dynamical force of the macroscopic scale, altering kind of the physical environment and, in our world, the very ecology of the world. Maybe I should say like the unintelligent activity of intelligent creatures. Okay. So let's go back to the epistemic arrow of time. The practical arrow I want to suggest is just the flip side of this. You can take the same ingredients, the current macro state, the canonical microprobability distribution, and the low entropy past. Okay? And now you're looking into a future about which you know only the kinds of things that can be derived from those three. And you ask, what should I expect the macro state of the world is going to be like, conditionalized on some macro event now of a kind that I ordinarily think is more or less under voluntary control. What if I, for example, walk across a sandy beach, drop an ice cube into a glass of water, scrape my knee, dig a ditch, or build a house? If I do some work to create an ordered state in the environment, and to answer the question, I just evolve the current macro state forward, and I can form some relatively reliable expectations. These things will leave an imprint, sort of scars on the world, records of their occurrence. If I walk across a sandy beach, I leave footprints. I drop an ice cube into a glass of water, I can expect to be there cooling the water in half hour. I work on more durable materials like houses and ditches. The records of my action will take longer to decay. And indeed, I choose my actions with an eye to their expected results. That's what intelligent agency is. It's acting with foresight and letting the expected results guide your actions. So how do things look over time as you make choices and act exactly as you'd expect? The future is a field of open possibility, transformed into the thin, hard line of fact, in part by your decisions. And notice here that I made no appeal to counterfactuals, only hypotheticals, drawing inferences that depended only on the thermodynamic gradient. I assume no causal arrow. The only thing that I've added to the ingredients above is that embodied intelligence is not detached, but engaged. It has interference effects, and it exploits those effects in the most immediate way by anticipating and arranging where it has direct control. But in a gentler way, kind of in the wider landscape, acting to forestall, avoid, and deter things that it doesn't like, and encourage, arrange, and facilitate ones that it does. So the interference effects are centered on my own body, and in your cases, on your own body. They're localized in space. They're going to run in the future direction for the same reason that records run in the past, or records carry information about the past. The interference effects of actions are effectively records of their occurrence. And I want to bring out now, what I want to bring out now is, what should my attitude to the future be? Okay. And the point here is that it's a little stronger than simply that my own decisions are going to provide me with information about the future that I couldn't have derived otherwise. It's that the potential for negative interference is going to keep me from being able to stabilize my beliefs about the future in advance. And the crucial thing here is that any prediction made in advance can be used as fuel to do something else, can be used as fuel for action. So if you have a system that's using information to guide its behavior, any attempt to predict it in advance, if that prediction is made known to it, is unstable because it can be used to undermine the prediction. So we know this phenomenon from the stock market and from political elections. Public predictions guide the behavior of the system itself. And there are people in the market and people in elections that are trying to outsmart it. And that's going to create negative feedback. So again, any prediction can itself be used when it's fed back into the system as fuel for overturning it. That's the whole point of knowledge. You're always anticipating the future, acting to deter, deflect, and counteract, to promote, encourage, and facilitate. Okay. Now, my control over the wider environment is always uncertain and derivative. So that potential for negative feedback, the effect, is strongest when it comes to my own voluntary behavior. So someone makes a prediction of what I will do, and as long as they reveal the prediction to me, I can act to do the opposite. Someone tells you they can predict whether you will raise your arm or blink. And if they share the prediction with you, if they agree to share the prediction with you, right, make a bet with them that they can predict. You put some money on it and let them try. You can win that bet. It's exactly the same as the example I started with. It's the potential for negative feedback that sort of animates the sense, I think, in life, that it's not over until it's over, so to speak. If you try to stabilize your knowledge of the future in advance of making your own decisions, okay, that can itself be used as fuel for overturning any earlier expectations. And you know for yourself when you're kind of making decisions that up until the last second, you can overturn any earlier expectations. The next thought will overwrite the first thought, and the one after that will override the second thought. You can go back and forth all night and decide to take the conservative route on some big decision. And then your partner says, oh, I knew you'd do that. And in a burst of kind of anger, you do the opposite. The basic point, though, is just that you can't stabilize your beliefs about the future without stabilizing your decisions. And you can't stabilize your decisions without making them. And until the moment that the decision is made, it can be overturned. Okay. Always loved this quote from William James, where he says, the great point is that the possibilities are really here, whether it be we who solve them or God working through us at those soul-trying moments when fate's scales seem to quiver, is of no small account so long as we admit that the issue is decided nowhere else than in the here and now. That is what gives palpitating reality to our moral life. Okay. Now, putting all of this, of course, in terms of interference effects and so on, sounds a little perverse. The way you would put it from an embedded perspective is my decisions make a difference to the future. And so the future is not fixed. But what we're just trying to do here is understand, or to recover that way of speaking, see why it arises and what it signals in terms that presuppose only kind of statistical mechanics and interference effects. So if I'm sitting outside a system and simply trying to predict its behavior, it's a different matter. It might be hard to predict what it's going to do because the system is complex or because there's missing information. But what's going on here is a different kind of thing. It's interference. It's the ability to stabilize the system independently of our predictions or our anticipation of what it's going to do. That's the point that I was trying to make with the kind of self-defeating answers of the computer and the self-defeating attempt to predict a system where you give it the prediction that you're making. In those cases, the problem isn't missing information, it's interference. And the potential for negative interference prevents you from stabilizing the future, your own future, as a potential object of knowledge in advance. So that's a sort of ham-fisted way of putting it. From a thermodynamic point of view, what's happening here is just that your actions will leave records and that you're choosing them with an eye to the records that they will leave. In principle, anything in the kind of choice-dependent region downstream of your decisions, that is, anything in your own future light cone, can sort of bear the marks of present action. But in practice, the interference effects are strongest and easiest to control in the immediate aftermath of action. Right? And the macroscopic effects are the ones that you can predict and control, and you build on them. So you're always thinking about what to do, acting on your decisions, living in the wake of your own decisions, plotting your next move. And when you're thinking about your own future, you're actively engaged in trying to shape it, right? Trying to avoid, forestall, avert. Of course, it's true that nothing you are going to do is going to make a difference to, for example, whether the sun comes up tomorrow or whether some captive panda in China has a boy or a girl, pregnant captive panda. But your day-to-day life is strongly centered on the regions of the world in which its own interference effects are strongest. And all of this is true, not because you're a magical thing that comes from outside of nature and interrupts the orderly kind of law-governed flow of events, but because you are part of nature and because your own thoughts and decisions are part of that law-governed flow. They interrupt it not from the outside, but from the inside. And your ability to act on your own knowledge is going to interfere with your ability to know in advance what lies downstream of your decisions. Okay. All agents, for the reasons I said, are relying on the thermodynamic gradient to some extent. They're using information contained in records to guide behavior whose rationale depends on its effects. Okay. So that's simple to see if you're just thinking about animals whose behavior was selected so that they're responding to the immediate signs of predators and prey. Sophisticated cognitive agents like us sort of harness that, self-consciously choosing actions with an eye to records that they will create at a temporal distance, kind of down, at a greater temporal distance. Okay, so interference effects arise because our information gathering activity is connected in the world, it's embodied, and it guides action in the very domain that we're getting information about. If agency is acting in the domain that we're representing, intelligence agency is recognizing that you're acting in the domain you're representing and exploiting the interaction effects to create a more desirable future. Now, the effects here are explicitly perspectival. Okay? The strength of interference between your choices and other events will depend on how your choices are connected in the world. They taper off quickly in space, and they're asymmetric in time. From a physical perspective, if you're a naturalist, minds are just part of nature. You making choices and decisions about what to do is just physics, part of the fabric of what happens. But from our own perspective, okay, we are making decisions about how things will go. And precisely because our current thoughts and experiences are an essential and integral part of the fabric of nature, they're going to interfere strongly with what lies ahead. Okay. So let's go back to just, examining the contours of this and seeing why it matters to kind of getting the psychological arrow of time right. There are two ingredients. There's self-reference and there's the thermodynamic gradient. The point about self-reference is entirely time symmetric. The asymmetry comes from the thermodynamic gradient. So whether you're explicitly representing your own knowledge gathering and decision-making processes, or you're just representing the publicly observable movements of bodies in the landscape, your knowledge is going to be connected in the world by way of its effects on the movements of your body. And the ripples of those movements, the records they create, are going to run into the future in a way that keeps you from stabilizing. Okay. So for an agent like this, looking into her future, there isn't the merely epistemic kind of unfixity. Something will happen, I know not what, but there's a kind of direct, practical kind of unfixity. I can myself act to forestall, avert, derail any antecedent expectations about what will happen. Okay. The future can be, for me, no more stable than my own decisions about what to do. Okay, almost done. So why does this matter? I think it doesn't matter for the practice of physics. So most often in physics, we're modeling other systems Even in cosmology, none of this is going to make a bit of difference to our ability to represent the universe at large scales. Nothing you do in the here and now is going to realistically make a bit of difference to feature of the universe that cosmologists study. So the sort of instability that comes from the fact that we are part of the world that we're representing is mostly irrelevant. But it does give us a better understanding of the psychological arrow of time. So it helps us to kind of slot in that last piece in the complicated structure in a way that I think solidifies its foundation. It does also help us understand ourselves, help us understand what time is for us. Our own personal view of the world is totally organized around that instability. Okay. The scale is much smaller and explicitly centered on the choice-dependent region in which the interference effects of our own knowledge are very strong. And of course, it's not an accident that that's where our kind of attention is focused. The whole point of your intelligence from a naturalistic point of view is that is the whole point of that complex loop of neurally supported computational activity that interrupts the perception to action pathways in your body is to use knowledge to interfere. Okay. Now, okay, so I put all of this in the most neutral way possible and refrained from drawing philosophical conclusions about things like free will or agency. All I've wanted to do is to try to get the pieces of our worldview to line up in a consistent way. Okay. From the outside, the universe is a seamless four-dimensional manifold. Right? And the manifold as a whole just is. Notions of past and future, fixity and openness, those things all have to be understood from an embedded perspective. So from the perspective of the decision-making agent inside the universe, I think the universe is rightly seen as coming into being as it is experienced. And the future can't be any more stable than its own decisions about what to do next. But what I want to suggest now is just caution against reading this in too thinly an epistemic way. So there's a very natural thought that you might have that this transformation of potentiality into actuality is still a purely epistemic one, at least in a deterministic setting. It's only in your mind that there's really a plurality of possibilities, because and the only reason you get to say that is because we're working with macro structures. And so forward prediction is limited. You might think from a physical point of view, right? In fact, if we're working in a deterministic setting, and let's just suppose we are, the initial conditions are in place. So there's really, once the initial conditions are in place, there's really only one possible future. Okay. Now, one part of this is correct. From a detached perspective, there is only what is. Okay. What will be, will be. Relativity unequivocally rules out the idea that there is any global directed process of the universe itself coming into being. So it rules out one way that of trying to be a realist about the transformation of potentiality into actuality. Okay. But if we restrict attention to kind of relativistically well-defined notions from an embedded perspective of past and future, and we consider the relationship between the absolute past and the absolute future at any point along the world line of a system in any of the kinds of local deterministic theories that we actually have examples of. Even if we fix the complete contents of the backlight cone at P, there are indefinitely many nomologically possible futures. And that is because you need to take the total state of the universe into account to fix the future, and that will always include events that are outside the past light cone of an embedded agent. So the reduction of potentialities and the reduction of potentialities, moreover, kind of happens in real time. The set of events that are nomologically, or as a matter of physical law, sufficient to determine an event E is not contained in the back light cone of any moment absolutely prior to E itself. And so that means that even if we gave an agent full micro knowledge of the events in her own past light cone, that wouldn't reduce the number of possibilities for her future. So the idea that there are many future possibilities is only an artifact of the macro perspective, that part's wrong, I think. The reason that our senses are sensitive to macroscopic structure that rather than microscopic is that cognition works on records and it works on traces. That's where the opportunities for using information to guide behavior are located. It's the record-bearing properties of the macroscopic environment, the fact that it bears the imprint of its macroscopic past, and that the future will bear the imprint of its macroscopic present, that agency exploits. So whether it's described in microscopic or macroscopic terms, as we trace a path up your world line, we see a process of your choices and actions. And the process that we see a process that includes your choices and actions. And those choices and actions are part of the process that transforms potentiality into actuality. So when you're looking into the future on the precipice of a difficult decision, the future does hang in the balance while you deliberate and is brought to a close at the moment of decision. All of that, I think, is literally true. Second, and maybe this doesn't need to be said, but the kind of interference that we're talking about when we say that the ripples of your own actions interfere with your ability to know the future isn't the kind of interference that arises when one object blocks another from view, or the kind that happens when you sort of turn on a light to check if your children were asleep, or if you try to measure something that's altered in the course of measurement. In those cases, there is independently a fact of the matter. That is, there's a well-defined fact that's independent of your choices to ascertain that fact, and your attempts are just unsuccessful. Right? In this case, I think there is not. Okay? It's more like you're trying to reach for a floating object in water, and the motion of your arm pushes the object out of reach. To get a proper understanding of this, I think this kind of interference, we can't treat ourselves as we mostly do in physics, as kind of sitting outside the universe, looking down. We have to absorb our own lives, including the thoughts and the deliberations, into the fabric of the universe as an essential and integral part of what happens. So we can't infer much about our futures from our pasts, or maybe at least much of what we care about in day-to-day life. So much of our kind of immediate macroscopic futures without passing through our own decisions. And that just means that all of the unfixity, unsettledness, the contingency of our decisions is going to bleed out into the world. And getting, I think, this piece right just shifts other things that matter. So maybe not so much to the actual practice of physics, but to places where kind of trying to assimilate physics philosophically, where the shoe pinches. It's just an important reminder that we're part of the universe, and a correction to the tendency to think about the universe from a transcendent point of view when we're trying at least to understand our own position in it. Okay, so lastly, the strong tendency to remove ourselves from the universe when we model it in physics, and then to think that the differences between the way things are, according to physics, and the way they seem to us somehow reveals that what we think pre-theoretically, or about the way they seem, that is, sorry, let me put that a little differently. This tendency is to think that the differences between the way things are according to physics and the way they seem to us reveals that the way they seem to us is illusory. But I think at least when it comes to understanding time as we know it, we need to abandon the fiction that we're outside the world. This is what it is to be part of the universe, not a spectator, but one of the players on the field. that's how it seems to you, and that's how it is from your perspective. Okay, all done.
Thank you, Jenann. Thank you.